All right, in section 11.4, we're going to talk about parallel and perpendicular lines. So on page 679, we're at the middle of the page where it says essential understanding. You can use the relationships of two lines to a third line to decide whether the two lines are parallel or perpendicular. So make note that you have to have three lines in order to do this. So theorem 13. If two lines are parallel to the same line, then they are parallel to each other. So look at your diagram here. We have three lines, A, B, and C. A is parallel to B, and B is parallel to C. Therefore, A is parallel to C. On the top of page 680, we have theorem 14. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So if you look at the diagram, it says that if M and T are perpendicular and N and T are perpendicular, then M and N are parallel. So it says, notice that in theorem 14 it includes the phrase in a plane. In exercise 17, you will consider why this phrase is necessary. So let's look at problem 1. The got it under problem 1 says, can you assemble the pieces below to form a picture frame with opposite sides parallel? Explain. So I want you to look at that yourself and see if you can do that. Now this is a really bad drawing, but yes, this will work. These would be your 30-degree pieces on the top and bottom. And on the sides would be your 60-degree pieces. Now it works because these all form 90-degree angles. All of these are 90-degree angles. But this is the important part. Why are opposite sides parallel? So why are the top and bottom of this picture frame parallel, and why are the sides parallel? Well, here's what we're going to look at. I'm going to draw the top and bottom, but I'm going to pretend that they're not segments, they're just lines going on forever. So if I have a line and another line, and I have this line, and let's say it forms 90-degree angles. Well, because theorem 14, and here's what theorem 14 says, that if you have two lines that are perpendicular to the same line, then these two lines are parallel. So, if this line right here is perpendicular to T, and this line is perpendicular, let's call this T, then we know that these two lines are parallel. And the same thing is true if we use these two angles, and if we use the other side. So if we actually did it this way. These form 90 degrees, and therefore we know these two lines are parallel. So that is the proof that the sides are parallel and the top and bottom are parallel because of theorem 14, which says, in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. That would be your reasoning. You'd have to write that. If two planes are perpendicular to the same line, then they are parallel to each other. So on page 681, in the middle of the page on the gray box, it says theorems 13 and 14 give conditions that allow you to conclude that lines are parallel. The perpendicular transversal theorem below provides a way for you to conclude that lines are perpendicular. So theorem 15 is called the perpendicular transversal theorem. It says in a plane, if a line is perpendicular to one of the two parallel lines, then it is also perpendicular to each other. So this one says that if you have one line perpendicular to parallel lines, so it's giving you that they're parallel, then that means that the transversal is perpendicular to the other line. So look at your diagram. It says if N and L are perpendicular and L and M are parallel, then N and M are perpendicular. At the bottom it says that the perpendicular transversal theorem states that the lines must be in a plane. The diagram at the right shows why. In the rectangular solid, line AC and line BD are parallel. Line EC is perpendicular to line AC, but it is not perpendicular to BD. In fact, lines EC and BD are skewed because they are not in the same plane. In problem 2, it says that we are proving a relationship between lines. So this is all about proofs. So in practice 2, developing a proof. Copy and complete this paragraph proof of Theorem 13 for 3 coplanar lines. So look at this first. Let's all look at this together. The given states that L and K are parallel and M and K are parallel. We want to prove that L and M are parallel. So here's your proof. Now this is a paragraph proof, but we can still fill in the blanks in your book. Since L and K are parallel, angle 2 is congruent to angle 1 by what? It would be because of corresponding angles. Angle 1 and angle 2 are corresponding. So A would be corresponding angles theorem. Then it says, since M and K are parallel, M and K are parallel as well, we can then say what? It says something is congruent to something. Well, blank B would say angle 1, and blank C would say angle 3, because angle 1 and angle 3 are congruent for the same reason. By the transitive property, we can say that angle 2 and angle 3 are congruent. And then it says by the blank theorem, L and M are parallel. Well, we can say what? The converse of corresponding angles theorem. So, the reason is because if you look at L and M are parallel because we just said 2 and 3 are congruent. So because 2 corresponding angles are congruent, we know that the lines are parallel. Remember that. If we have parallel lines in a transversal, corresponding angles are congruent. Well, the converse of that says that if you have 2 corresponding angles, then the lines are also parallel.